Hello there. In this video we're going to be recapping this Sony TV. I'm going to do it over a couple of evenings, so you might see me change clothes or things are slightly different in some shots. So what we're going to do is we're going to dismantle the TV and get it ready to basically go over it and have a look and see what's there. I've already discharged the CRT, that's already done, that's pretty much here, and I've taken the anode cap off. And let's get on with it. Right, okay, so first of all, anode cap is off, and I'm just going to disconnect the power cable here. It's a pretty easy clip to undo, and we can remove this out of the way. So that's all out of the way. Right, I've disconnected the cable for the speaker. I'll just pull this back out. So here we have the main CRT driver board. So we're just going to disconnect that. The great thing is that they are actually keyed, so it's quite easy to do. We've got this is the ground across the actual CRT, and then we've got the yoke connector. That. This TV's been off for a few days now, and I have checked in a few places, and yes, pretty much it's all been all of the capacitors have been discharged. So I'm just going to take this off. So basically I'm disconnecting the driver board, the CRT driver board, the neck board, and so there we are. There's all of the grounds for the ground wires which connect all around the CRT. Then this is the degaussing coil, and just get that, and we have one board out. So if we just clear this up a little bit. So let's just check whether you're in shot. Yeah, you're in shot there. Let's just zoom in a little bit and just move that down. Right. So, okay, let's have a quick look around here. I'm just sort of really looking for any burnt resistors or diodes that look a bit toasty. So let's move that there. And again, what I've done in the past, this is the TV which I've already dismantled and done a few bits and pieces to, is I always put a mark on all of the capacitors here so that I know these ones need replacing. Yeah, pretty much. Now this is what this is the here. This is the teletext board. So let's have a look. Yeah. Click that, and two, and I think I'm going to need a tool of some sort. Come on, in. So just remove that one. Try not to break the plastic tabs. They're very, very delicate now that they're so old. these little plastic tabs, they just snap. Now, if I remember correctly, this actually fell off the back of it. Right, there we go. I'm just going to check focus. Yeah, there we go. So, the edge of that board there. I just want to make sure that you see as much as I can with my setup. So, yeah, standard board. The quality of the components is pretty high on these. They're quite reasonable. Just really looking for anything a bit suspect. I'm just gonna, yeah. There we go. So, 2, 3. There was a brightness control somewhere. We'll find it. It's here. Right. Yeah. It's had a bodge wire, and that does look original actually. That sort of does look original. And up here there's been a bodge wire. It looks like something to ground. That's the IC 551 chip, which I need to check this up. It's actually a TDA 2579A chip. I'll have a look that up later and see whether they've tied pin 1 to ground on that one, to find out why later. Often with the flyback transformers, they seem to crack their traces quite a lot, and in fact there's actually already the start of traces here, which are as the solder joints are just starting to crack here. That's a very commonplace on most CRTs, where basically they seem to crack. It's down to heat and expansion and contraction and the weight of the actual component on there as well. Just looking. Yeah, I can see a few solder joints that are looking a bit naughty at me, winking their eyes at me. That's in that SCART connector. Yes, I can see a couple of joints, which could have been the reason why this did what it did. Actually, this is this is the other one. This is the one which basically the yoke connector was bad. But again, I can see one there. That's on a capacitor. So a little ceramic capacitor just to there. Yeah, there's definitely one there. I'm not entirely sure. Let's see whether I can move my cup out of the way. Just there. There's one there. Let's see whether I can zoom in. There we go. There's that one there. So that's starting to look a little bit dodgy. Apologies for the camera work. I'm not set up fully for this type of stuff, so it is what it is. Right, yeah, there we go. Yeah, I think a lot of these just need reflowing. There's quite a few dodgy solder joints, and there's the conformal coating. I can see some gaps in it, so, and also I can see fingerprints as well. Might be mine, I'm not sure. Yeah, around the high voltage there are quite a few dodgy solder joints here. Yeah, I pointed that one out. Yeah, there's one there, one there. Yeah, so what I'm going to do is I'm going to basically start going through the capacitors. and also I'm going to do a diode check as well. So I just want to check a few of the diodes, make sure that everything's all okay. So let's, no, I can't. Yep. Right. Yep. Yep. Yep, that's good. Yep. Yep. So most of the main large diodes all seem to be good. Yep. I think we can start recapping on this. I think this is, I said, this is not about economic restraint, and this is about making sure these TVs and monitors actually work for as long as possible, and they're going to be in a high hour environment, so it's a complete waste of time just trying to fix only one or two components. Just recap the whole board, and then we know that then all the capacitors are good, and we can then we've got a higher chance of this actually surviving, being on 8-10 hours a day for the next 10 years or 5 years. These monitors and TVs are already nearly 40 years old. So interesting thing is this capacitor, whether it was a manufacturing defect, but the plastic covering hasn't gone all the way over the top. Looks like it's shrunk slightly, so it's possible that got popped. Right, let's crack on with it. You're going to hear a lot of noise. This is my desoldering gun. It's the same Dura tool, which, yeah, come on, wake up. The problem I have is I'm in a cold. Oh, there we go. That's better. Right. So this is our first cap we're going to do. So the really big one. These rarely go wrong. These really, I don't know whether you can see. Yes, these rarely go wrong at all. But we're going to replace it anyway. So this is the main cap on the AC. Yes, that's the bridge rectifier there. Main power comes in over here, across there, through an inductor, 3.3 ohm resistor, bridge rectifier, So we've pretty much done all of the main power caps. There's a few in there I'm going to do later on. So I've got decoding, got teletext control. So yeah, I've still got all of this to do as well. So yeah, I think that's it. Right, this is part one. End of part one. There'll definitely be a part two, and I'll be coming back to this, and then basically I'll probably start on this side of the board, finish those ones off and that one. It's cold in here. It is 12 degrees, and I need a cup of tea. Thanks for watching, and look out for part two.